So in figure 6.24, I want to call your attention to this one in particular, this land surface, and we're discussing artificial drainage. So drainage of a field through a man-made mechanism or technology or something like that. So we call this what I've highlighted here tile drainage. And tile drainage it used to be with clay tiles. That's why we would call it tile drainage. It's not with clay tiles anymore. Let me bring up this picture. Now what it is perforated plastic perforated plastic tubing. You bury this in the soil, and since this tubing is this tubing right here is perforated, it allows water to move inside the tubing, and then we can move that out to the edge of the field and have that deposited in a ditch or something like that. And what we're seeing in this tile drainage in this picture up here is the effect of a tile drain. So you can see where the initial water table is. Sorry, initial water table is right here. When we apply one of these, let me show you a field view of what this might look like. So we've got our plants growing in a field. The water table, the height of the water table, or let me talk about two different things here. So there's a couple things we can think about. Number one, how high is that water table? That'll determine how close together we space these tile drainage. If we do them very far apart like this, or if we do them closer together, it really depends on the height of this water table and how far we want to move this water table down. So that'll determine where we actually put these and how far we space them apart from each other. So you can have a lot of variables in this, and people that do tile drains, we have a few of them in the West, but they're way more common in the eastern part of the United States, the Midwest and the eastern part of the United States. Let me draw this real quick. So again, let's say we spaced two tile drains like here, and let's say they were spaced 30 feet apart. Okay, the water profile, it's not going to go just directly down to these. Let's say we start here with our reference water table level. What'll happen is you'll see a drawdown like this happen with these two tile drains. Again, it won't go all the way. It won't necessarily go all the way down to that tile drain, and it won't be flat across like this because these are, the tile drains aren't 100% efficient. But you'll see the drawdown that looks something like this, so that plants are able to, extend down into the soil. The roots are able to extend down into the soil and have room enough to grow. So this is what tile drainage looks like when you actually place it in a field, and you have to think about spacing. Soil texture will play a role. So root depth, texture of the soil. Okay, these things will make a difference too. Let's see, water table height. Okay, these sorts of things are the calculations that we use, or the inputs we use to determine what the spacing and the depth of our tile drainage will be in a particular area.